Hello, Natalie.
Hey Pete,
Natalie. How you doing, hon?
I'm good. How are you?
Oh, you sound tired.
Yeah, I'm so tired. I barely slept yesterday.
Okay. Well, we'll take it easy. Don't worry.
Thanks, Pete.
Now, question for you. Did you do any of these?
Yes.
Oh, you did. All right. This one looks hard, doesn't it?
Wait, what?
These.
Yeah.
Okay.
Oh, yeah. I looked over them,
Oh,
but I know how to do it.
I know you know how to do it. What did I always tell you about tests and avoiding freezing? It has nothing to do with memorizing how to do it.
Just practicing.
It's practicing so you can do it fairly quickly when a test hits, because otherwise you're stumbling, right?
Yeah.
Okay. So I'll expect you to do this. You can do it whenever. But what I'd like you to do is to look at this very hard one. So all we're going to do is we're going to complete the square to find the vertex. The problem with this one is, you'll notice, it has odd, weird looking numbers. It doesn't have
Yeah.
nice and smooth numbers. Got 0.28 in the front. By the way, does this parabola face up or down?
Up.
Yeah. So that means we know it's going to have a minimum point. And the minimum point is going to be the vertex. Now, if this said 28 squared, 28x squared minus 7 plus 10, 7x, you would know very quickly how to do it, right? What would be the first thing
Yeah.
you'd do? What would be the first thing
First we
you...
divide by 28.
Yeah, the first thing is we got to get rid of this 28. So you divide the first two terms by 28. Notice that 7, you'd be tempted to put it into decimals, but 7 goes into 28. It goes into 28 four times. And it goes into 7, 7 divided by 7, 28 divided by 7. 7 goes into 7 once. So this is the same as this fraction. Because
Mm.
7 goes into 28 four times. Whenever you want to simplify a fraction, you can see if they divide both by 7. Hang on, I got to sneeze. Oh, I hate that. Okay, so you're right. Normally we divide both terms by 28, and we'd be left with this. We'd have a 28 in front, and we have an x squared minus 1 over 4x, and we'd have our 10 way over here. Like that, because this is 7 over 28, which simplifies to
Which is
1
1
over
over
4. Great. Now, completing the square is the same process as always. We would have this number. But we went in through the complicated process of having a fraction. How do I divide this 1 over 4 by 2?
4. You're gonna put the 2 over 1. 1 over 2, and then multiply.
Yep, it's up there. That's 1 over 2. And what do you get?
You get 1 over 8.
Yeah, that means the completion of this square is 28x minus 1 over 8 squared plus 10. But that completion of square creates a number that we have to subtract. What is that number that it creates?
The square of 1 over 8.
Yeah, the square of 1 over 8 is the same as 1 over 8 times 1 over 8. What's 1 over 8 times 1 over 8? This is easy.
1, and then 8 times 8, 64.
Yeah, it's 1 over 64. So that means we'd have to subtract 1 over 64. But this is in the big bracket, and it has to get out into the outside bracket. How do I do that? How do I get it out here?
Multiply by 28.
Yeah, and it happens that 28 goes into 64. 28 can be divided by 28. And 64 can be divided by, let's see if 64 can be divided by 28. Nope. So let's start with dividing them both by 2. We get 14.
So we get 14 over 32.
We can divide those by 2.
7 over
16.
16.
That's the simplest fraction. So that means to get it outside, it would become minus 28 over 64. See, we don't even have to divide it, really. You just leave it like that. In this case, I simplified it. 7 over 16. Over 16. And it's the same fraction when you simplify it. And then the square goes here, and we get rid of this number in here now. Well, actually, I've already got the square right there. We're left with this, 28 times x minus 1 over 8 minus 7 over 16 plus 10. 16. 10 is over 1.
So now we have to add those.
Yep. How?
Um,
That's why we practice. This is why we practice, Natalie. I want you to do these tomorrow because you don't want this mark.
okay.
Right? This is the
Yeah.
whole point. You got to be able to do this. If you spend an hour doing this one question, you get a bad mark. And the whole point is speed. So to add fractions, we need the denominator the same. What's the denominator over here?
16.
So I can either multiply this fraction by 16 over 16, this fraction here, or I can cross multiply. What's 1 times 7?
7.
Yep. What's 16 times 10?
160.
We got 7 plus, because there's a plus here, and we got minus 7, because there's a minus here. Minus 7 plus 160. And what's 16 times 1?
16.
All over 16. So we have to just figure out what's minus 7 plus 160. It's the same as 160 minus 7.
153.
Yeah, 153. So this is our final thing. So that's pretty straightforward. And you can just leave the fraction like that, or you can take your calculator and divide it. Oops. Okay, so this would be the coordinates of the vertex. Either of these two is correct. This one visually tells you where the vertex is, though. Where's the vertex?
It's at negative 9.5625.
No, vertex is here and here. Try again.
Oh, negative 1 over 8. And
No.
what do you know here?
I love it. There's the teenage sass. It's not negative 1 over 8.
Oh, it's positive 1 over 8.
Thanks, Sleepy
And
Natalie.
negative,
Yeah.
negative 9.5.
This one always stays the same. This one's always the opposite.
Yeah.
That's right, Sleepy Natalie. So it's below the x-axis, too, because we're at negative 9.625. Now, you might say, Peter, those weren't the numbers. But they were. We're just going to do it with this one now. Ready? How do I get rid of this?
So you're going to have to divide by 0.28.
Yep, both of them. Let's see if 0.7 here can go into 0.28. In other words, what happens when I take 0.28 and divide it by 0.7? Oh, I get 4, or 0.4. And how many times, what's 0.7 divided by 0.7?
Uh, 0.1,
Oh, what's 5 divided by 5?
1,
8 divided by 8?
1,
0.7 divided by 0.7.
1.
Yeah, any number divided by itself is 1.
Okay.
Yeah, so that means if I take these two numbers and I divide it by zero point 0.7 and it by zero point 0.7, I get 1 over zero point 0.4. But let's get back to that in a second. I'm taking 0.8 out. This is what I'm left with. X squared minus, which is what I want, minus this. Hang on, let's clean it up a bit. Okay, I got 0.28 hanging out. Minus this. And we can't forget that plus 1 over here. All right, so this can be divided by zero point 0.7, and this can be divided by zero point 0.7. Let's do that bottom one divided by zero point 0.7 and determine what it is. Or we can just leave it like it is. Let's just leave it like it is. Now, how do I figure out the completed square? It's half that number. It's the same thing we did before. How do I half a fraction? Well, it's
You
this.
have
Yeah?
you
Divided,
have to
divided by
um
2.
use the rest divided by 2 over 1, but it's going to be 1 over 2, and then multiply it.
Yeah. Well, this is easy enough. Just zero point 0.7.
0.7 over
And if we did our calculator, we discovered this.
56,
Yeah.
0.56.
Yeah. Now, notice that the half of a fraction is always the same number up top over twice this because of this. Every time we half a fraction, we get the same number up top and double the denominator.
Oh,
Yeah, over and over and over again because we always end up multiplying it by half. Great. That means that the completed square is this. We can't forget that pesky plus 1. Here's why I just left it as a fraction like this. How do I get this? Oh, now I have to subtract something. I have to subtract
the
it.
square.
Yeah. Yeah, I don't want to hurt my brain. So the square of zero point 0.7 over 56 is simply zero point 0.7 times zero point 0.7 over 0.56.
So 0.49.
Ooh, let's make sure though. I think you're right. Ooh, 0.49. Ooh, that's the tough one. It's really this. We have to subtract 0.49 over this. Ah, Peter, I don't like fractions. Yeah, well, we'll just leave it like a fraction. How do I get that out of the bracket?
You have to multiply by 0.28.
Yeah. So I'm just going to, since it's 0.28 over 1, I'm simply going to multiply 0.28 times this and leave that like that, right? It's going to come out, it's going to be the same number at the bottom. I have to take 49, 0.49. That'd be negative. I'm going to multiply it by 0.28. I'm going to get this nasty number. Yeah, no. But at least it's, let's put it up here for now and get rid of this. At least it's out now. At least it's out. And I'm left with this. Ugliness. Ugliness. This minus is really fun like that. Good. I'm almost done. I just have to find a way to add these.
Plus 1 over 1. So you have to find a common denominator.
Mm-hmm.
You're just going to cross multiply.
Mm-hmm.
It's going to be negative 0.1372
Mm-hmm.
over 0.3136.
Plus 0.3136. Why? Because when I cross multiply the right side, it's a plus number. This negative belongs to this one, not to this one. Plus times this 1 plus this. All over what?
0.3136.
Yeah. Woo! Now I just got to add these together, the numerator. And I get this. It's important to stay in the fractions because if you keep turning it into decimals, it gets more and more inaccurate. Whereas if you keep it in fractions, it's incredibly accurate. And mathematicians will often stay in fractions because mathematicians like accuracy. Ooh. So that is technically the vertex format, where this is the x value and this is the y value. But I can also turn both of those into decimals. I'm going to start with this middle one. You might say, Peter, why didn't you just do that in the beginning? Because your teacher might want both.
Yeah.
So we get this inside the brackets. Squared. And then when I do the other fraction, negative 1762. Clear, 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 clear. 0.1764 negative divided by 0.3136. I get this. Great. A little clearer. It's a little clearer. There we go. So if your teacher wanted the fraction vertex, it would be this number, comma, comma, this number. And if your teacher wanted the numerical value, it would be this number, comma, this number. Make sense?
Yes.
All right, but now let's go back to the question at hand and ask ourselves, what was the original question asking? What does this? What does that mean? Determine the minimum production cost. First of all, let's go back to our equation. What is x in this equation? It says in here. It says in here where x is.
Cost per hour.
Nope. Keep reading the question. C of x is the cost per hour. C of x is over here.
Oh, X is the number of items produced.
Yeah. So it looks like
Over.
however many number of items I produce, that's how much it costs. This is an upward or downward.
Upward.
So that means I want to minimize my costs. I want to have the bottom of the vertex to figure out what the cheapest cost is and the number of items.
So that's the vertex that we found?
Yeah, so we've determined that based on this, not that one, the other one, which I think I've erased. Let's see. We've determined that if I make 0.42 items, I keep my costs down. to negative 0.56. And you might say, well, that doesn't make any sense. Except that if we go back to the question, it's in,
Thousands.
yeah, in thousands. So I would multiply that by 1,000. I get when I make 420 items. This is in the millions. So when I multiply that by million, I keep my cost down to nice low negative $562,500. Now, let's make sure we got this right by taking this formula and putting it into Desmos to see if we got the correct bottom of the graph. And we might not have. Doesn't matter if we didn't. We can call it C of X.
Why didn't we have it?
Huh?
Why do you think you
Well, because
didn't?
it's so complicated. The numbers were so
Oh,
complicated that our chances of making a math mistake with really complicated fractions is much higher than our normal situation. Now I'm going to call the second one just Y. And I believe we had this information, 0.28 in front, x minus 0.42. And the question just becomes, are these the same graph? Got to get the other value in there. Minus 0.5625. 5625. No, look at that.
what? What did we do wrong?
Ah, it's very easy to make a mistake. Oh, this I might have written this right. I don't think I wrote that right. 0.42 negative
What? That doesn't make
0.59.
sense.
No, it's just a mathematical error that we made somewhere. Now,
But how?
well, I don't know. Here,
Maybe if
so
you
let's
put in
cheat.
the
Let's cheat.
fraction.
Huh? Let's cheat. Let's cheat. All right. I'm going to go back here and watch how fast I can do this. I know from experience now that I need to get that 0.28 out. When I do, I'm left with x squared minus 0.7 over 0.28. And I know from experience that I need half that number for the completion of the square. And I now know from experience that half of a fraction is just double that. Right?
Yes.
So this is my
0.7856.
completion of the square. So now all I do is I don't have to complete my square. I have my x value. So let's first see if I got my x value right. 0.7 divided by 0.56. Oh, and I've got to multiply it by... No, that'll be the half. Ah, look at that. I got it wrong.
What?
Yeah, let's try it again. Clear. 0.7 divided by 0.56. Yeah, got it wrong. That means my completion of the square is actually negative 1.25. Getting close.
How did we get 42?
Huh? Where?
How did we get 42? I forgot.
Yeah, we did a fraction and we divided it and added and whatever.
Oh,
So we did something wrong. And then to get that out, or I have to subtract but I'm not even going to bother. I'm going to take this ends up being 125, negative 1.25. And I'm going to do my partial completion of the square. I'm going to put 125 into this equation. And look at that, we got the y correct. But somehow we did the wrong fraction here. Let's see. Yeah, but then why aren't my graphs the same?
maybe it's the y value of our text.
Yeah, but I just found the y value right there. So let me just see. A half of 0.7. I'm going to take 0.7. Get 0.7 divided by 0.28. Half of that is that. So I got that right. Oh, this isn't negative. Stupid. There we go. That's the actual correction. So we did some sort of mathematical calculation that was incorrect. And maybe we should have worked with decimals to make it easier. So I will get you to redo that question using what you love to use, decimals. Just don't round them up. So that means when I make 1,250 units, my minimum cost is 562. 500. That's because I multiply my cost by 1,000,000 and I multiply my units by 1,000 because the question said in thousands of units, thousands of items produced in millions of dollars. So I multiply the dollars by 1,000,000, the Y value by 1,000,000, and the items by 1,000. So I determine my minimum production cost, and minimum production cost is 562,500 because this is my Y value, right?
Yes.
But it's in millions of dollars. So I have to take that,
and multiply it
multiply it by 1,000,000. And that's my minimum production cost right there. 562,500. 500. It's when I make not 1.25 units, but I take my 1.25 because I'm working in thousands of units. If they'd ask me how many units is that, I would say it is 1,250 units. And it'll only cost me 562,500 because that's the bottom of the vertex. Does that make sense? Now, Desmos rounds it up here. This is the actual. No. But does that make sense?
Yes.
Now, the lesson here was complicated math is more likely to make mistakes. Double check if you can. But notice how slow we went because we're not practiced. So if you take forever on this question, you'll get a low mark on the test. So this is my other hint for you. Do all the easy questions first in a test because then you'll have most of the test answered. Then focus on the next easiest because you want the most marks. Then do the hard question.
Last.
Yeah, because by then your brain will be loose and relaxed because the easy questions will make your brain go, this is easy. And then your brain will relax. But there's nothing worse than getting tests and going, oh my God, I don't know this. I don't know this either. I don't know this. I don't know this. I don't remember this. We didn't do this. And then your brain just goes. So
my next test it's on Wednesday.
Okay, so you want to focus. Did she give a review test?
No.
Those would help.
She never gives me the
Does
test.
she tell you what it covers? What's covered? What section?
Yeah. Let me pull it up right now.
Yeah, that's important to tell me what the test reviews are.
It says it's a 3.2 to 3.6.
Okay, there's 3.2. Oh, okay. So at the back of the book, you'll see some lovely questions. So we're going to do some of them. Some of them are easy. Okay. So this is what we're going to focus on for the test. 3.2 is here.
Oh my gosh, and radicals too, Pete.
Yeah, I know.
I kind of got it, but
Wait, what?
I kind of understood radicals when she first taught it, but I don't know. I haven't covered that in a long time.
Yep. Yeah. Well, we're going to have to practice and see if we can answer. Oh, is she including 3.3 because that's inverse. She said
Yes.
she's including 3.3, but she didn't tell you how to do an inverse?
Yeah,
Well, that's stupid.
I know. So stupid.
So she said we're going to skip inverses, but then she introduces inverses of quadratics?
And
That's insane. Okay, well, no wonder kids are failing her class. All
I
right,
know.
so there's
Yeah,
3.4.
wait, actually, she never taught
No,
3.3
you can't
last week.
suddenly can't suddenly ask students to do inverse of radicals when you didn't teach them easy inverses. It's nuts, right?
Uh,
Well, we'll do our best.
Maybe she was going to introduce it this week for the test.
Whatever. It's complicated. To 3.6, you say?
Yes.
Okay. Well, 3.5, we've been sort of doing it. Right? We've been doing models. That's what we've been doing.
Pete, do you think we could practice on both Monday and Tuesday?
Yeah, we can do that. Problem is, Tuesday I have a 4 o'clock student.
Okay.
I'm not.
Whenever you're available, even in the evening if you're available, I'm
Yeah,
available.
I'm available late, but cramming Tuesday night is bad. What time you get home?
Around 4.
Okay, let's do 5.
Okay.
Okay, grab a bite to eat and whatever.
Okay.
But I would also suggest if you want a good mark, when we hang up, spend about an hour and a half today and an hour and a half tomorrow going over these questions and saying, oh, I don't get this one, or yeah, I get this one, or I don't get this one, or whatever. Okay,
Okay.
and we'll even look at 3 point. She said 3.2 or 3.1.
3.2 to 3.6.
Okay. Jesus Christ. Mm. Okay, let's just quickly answer these. Ready? Which of these have a minimum value? Or sorry, which one of these have a maximum value, and how do you know?
Um, Maximum if it's facing
Yeah,
downwards.
so all we have to do is identify which ones are facing downwards. Which ones are facing?
So A,
Yep,
C,
yep, and done. State the vertex of each parabola and indicate the maximum or minimum value. Here's just reading the graph. That's -5, I'm a -2, and that's 4,
and then
comma
the
8. I'm not going to bother
minimum,
with the annoying ones. Determine the maximum or min value for each. What about this one?
determine the maximum and minimum value.
Yeah, so
A
essentially just
has
state the vertex.
A has a maximum value of -1/6. I
Yep,
mean -1, 6.
yep.
Um,
Mm.
B has a minimum value of +5 of 0.
Yeah.
C has a maximum value of
Oh, careful. They've done a little trick here. This is
the
not in what this is not in which format.
vertex that's factored form.
Yeah. This one is technically in vertex, so let's go to this one. Notice that these did not have any y values. This one technically doesn't have any x value. What do you think the vertex is there?
So it's going to be 0, positive.
No, we don't ever reverse the y value. This is a
Oh
y
yeah,
value.
so 0, -7.
Yeah. It's just there's no x transformation. This one, however, is in factored format. We could probably expand it, complete the square and all that. Huh. But it's well worth covering, actually, of how you figure that one out.
Yeah.
Okay, where was it? Right there. Ah, mm, mm, mm. So if we look carefully, this is clearly in a factored format, which means we can determine the x-intercepts, by looking at where each of these is equal to 0. So this is one intercept, and technically this is another one. So we can say, when does x minus 4 equal 0? This is how we find the intercept.
Okay.
How do we solve for that? When,
When is what?
when x is
0?
No, because 0 minus 4 does not equal 0.
Oh, when x is
Yeah, well, you can solve it algebraically by adding what to each side?
4.
Yeah. We're left with this. What am I left with?
X equals 4.
So that means one intercept is 4, comma 0. Then we have to just solve the other one. When does...
Hold on, Peter.
Yep.
Yeah? No, I'm studying with Peter. Sorry.
When does this equal 0?
Um,
You can solve it algebraically. What would I have to divide by on both sides?
2.
No. What's that?
-2.
This appears here. What's
Oh,
0
sorry.
divided minus 2?
Mom, I'm studying. My God. And continue.
What's 0 divided by minus 2?
It is 0, 0.
Yeah. So that means the solution here is x is equal to 0. So where's the intercept?
Um,
X is equal to 0 means the intercept. It's also y is 0. So where's the intercept?
it's 4.
No, we already did 4. That was this one.
Oh.
We're solving this one. We've discovered x. This is true when x is 0. This is true when x is 0. So where's the intercept?
0,
Comma?
comma 2.
No. When...
Sorry, 0, comma 0.
Yeah, it's at the y-axis. So that means when we have this all alone, one of the intercepts is 0, comma 0. And you just have an x like this. That's because for this to be true, this is how you solve them. You make them equal to 0. For this to be true, x must be 0. That means one of the things is origin. This is facing up or down?
Down.
Down. So these are the two x axes. 4, comma 0 and 0, comma 0. So somehow it's doing this. Huh. How do you find the x value of the vertex? It's the same as the axis of...
Symmetry.
What's the axis of symmetry between 2 points on the x-intercept?
It's going to be 2.
2. So I can just take this 2 and put it back into the formula, right?
Yes.
Okay. So I'm going to rewrite the formula, but everywhere I see x, I'm going to put a 2. I'm going to try to make it a little smaller so that I don't get too crowded. Let's solve this. What's negative 2 times 2?
Okay, it's 2 minus 4.
Thank you. What's negative 2 times 2?
Negative 4.
Yeah, what's 2 minus 4?
Negative 2.
What's negative 4 times negative 2?
Positive 8.
Yeah, so that means when x is 2, y is 8. So that means we have a vertex at 2,
Comma 8.
8 right there. So remember that. You've got to be able to find the x-intercepts, and halfway between is the axis. Plug it in, you find the vertex. But this is factored format, which means each of these must be set to equal to 0 to determine the x-intercepts. When there's an x all alone, no matter what it's multiplied by, it means one of the intercepts is 0, comma 0. So
Okay.
I'll show you some quick desmoses to show you. I'm going to write a bunch of factored formats. Here's one factor, and here's the other. Notice it goes through 4, 0, and 0, 0. Okay, let's do another one. Here's 52x, and then x minus 6.
Yes, yes. Peter. Okay, continue, Peter.
Yeah, notice the 2 intercepts for this one.
Oh.
That means when we have an x all alone here like this, it's always 0, 0. It doesn't matter what number I put in front of it, it still goes through 0, 0. This just stretches it or compresses it. Still goes through 0, 0 because that x is all alone. Now, if that x wasn't all alone, Guess where the intercept is now? Where are the two intercepts?
2 and 6.
Yeah, 2 and 6. What's halfway between 2 and 6?
4.
Yep. So that means if I put 4 in here, I get 4 minus 2 times x minus 6. Sorry, 4 minus 6. And it gives me the answer right there. That means my vertex is at 2. Or sorry, 4. Comma minus 444. And now just to prove it, there it is. What did I do there? I figured out my axis of symmetry,
Yes.
which I knew was 4, and I put 4 where I see x. To solve for y, it tells me y is this. That means my axis of symmetry is that. So for instance, 4 minus 2 here is 2. 4 minus 6 here is minus 2. Minus 2 times positive 2 is minus 4. Minus 4 times 11 is minus 444. So you can always find the vertex if you know the two axes of symmetry. You find the middle point. And if it's a weird number, you can always take 2 and add it to 6 and divide it by 2. 2 plus 6. So you always add the x-intercepts and divide them by 2, and that'll tell you the axis of symmetry. You add them together, divide by 2. Because they're gonna definitely ask you to do that. Okay, we're gonna keep going. Okay, just you don't have to do it. Tell me how we would determine the maximum and minimum here. What format is that in?
That's in standard form.
So we would have to what?
We would have to complete the square.
Yeah, and what I can do partial if I'm on a test and I'm in a hurry. I notice that look, my x value is going to be half of that because there's nothing in front of this x squared, is there?
No.
What's half of minus 4?
Minus 2.
Yeah, so that means my partially completed tells me I'm going to be with this. What's the x value of my vertex?
Positive 2.
Yeah, so now I go back and plug positive 2 into this formula. You go, okay, well, positive 2 squared is 4. Minus 4 times 2 is minus 8. So 4 minus 8 is minus 4. Minus 1, minus 5. I've discovered the vertex is 2, comma, minus 5.
Wow.
Yeah. Pretty fast with partial completion, isn't it? What's the
Yes.
x value of the vertex with this one? There's no number in front of the x squared, so it's simply...
It's simply minus 4.
Yeah, but it's x minus 4 squared, which means the x value of the vertex is actually...
Wait, x minus 4 squared.
If it says x minus 4
Oh
squared...
yeah, it's positive 4.
It's positive 4, so that's the little mistake you can make. Forgetting to do that. This is technically also completion of square, but I got to take the 2 out. So if I divide this by 2, the 2 just disappears, doesn't it?
Yes.
And if I divide this by 2, I'm left with?
6x.
Yeah, what's half of 6x?
3.
Yeah, which means my completed square is x plus 3, isn't it?
Yeah, so it's going to be negative 3.
Negative 3, and we plug that back into this equation. If I'm in a hurry, negative 3 here squared is 9. 9 times 2 is 18. Negative 3 here is negative 36. So 18 minus 36 is minus 18. My vertex is... did I say? My vertex is minus 3, comma, 18.
Minus 18.
Yeah, minus 18. Thank you. So boom, got it. Same with this. I got to divide them by minus 3. I got minus 12 divided by minus 3 is plus 4, and half of that is 2. So it's x plus 2 squared as the vertex, which means my x value is minus 2. I can continue on and complete the square. This is factored format. What are the two intercepts? The plus 5 doesn't matter.
Wait, isn't that vertex format?
Nope, because there's no square outside this bracket.
Oh, that's right.
This is a factored format, and the whole thing is raised by 5. And actually, yeah, because it's raised by 5, We actually can't do it. We'd have to expand it, turn it into standard format, and complete the square. This is in vertex format.
Yes.
What's the vertex?
It's -1, -5.
Yeah. Each function is the demand function. Oh, I hope she doesn't do that.
Wait, Peter, I'm sorry, how do we turn e into standard form?
Okay, expand it. 3x times x,
Is
3x squared.
2x squared
3x times minus 2.
is, so would it be 3 minus 2?
No,
I mean 3
I'm
times 1.
expanding it. I'm foiling the bracket. I'm foiling the bracket. So let's do this one. Okay. When presented with a weird thing that you're not quite sure how to resolve it, you can always turn it into standard format by foiling it out. By foiling it out. So to foil it out, yeah. To foil it out, I have to do this. 3x times x.
3x squared
Yeah. 3x times minus 2.
is
Do you see an x there?
negative 6.
Huh? Say it again?
Negative 6x?
Yep. And then we're left with a plus 5. Now we have a
Okay.
standard format. What do I have to divide the x squared by? To get
By 3.
yeah, I have to get the 3 out. I'm left with this. How do I complete that square in the middle?
You have to find the square of,
Nope, not yet. It's not a
sorry, you
completed
have to
square.
divide by 2.
Yeah. So what's the square?
It's going to be 1. So it's going to be x minus x.
Oh, the x
Or
is
1.
not included.
Yeah.
When we complete the square, the x disappears and it becomes this.
So then the perfect square is going to be -1.
Yep. I have to subtract 1, but that 3 in front means
So you have to multiply
I have to,
by 3.
yeah. What happens when it gets out?
It's going to be -3,
Plus 5. It's negative 3 plus 5.
+2.
There we go. You completed the square. What's the
Um,
vertex? What's the vertex?
+1, comma 2.
Yeah. Now, at this stage here, because half of this means this, notice that there's no x here anymore. There's no x. It's just half the number. I know that I know that 1 is the vertex. I can just go back here and plug it 1 in. 1 minus 2 is -1. 3 times 1 is 3. 3 times -1 is -3 plus 5, 2. I get it. 2.
Okay.
Partial completion, right? I just put the 1 back into the equation and it spits out the 2 that we figured out with completing the square. Yes? You understand or not?
Yes.
We're going to skip 5 because she's got to teach that and it's stupid. Graphing calculator we're going to skip because that's just like using Desmos. Oh, we did these. So you should review it. Profit is always revenue minus cost. But the trick is the minus has to be applied to both these things. So it becomes this whole thing minus 12x minus 28. Remember that we did this?
Yes.
And then you have to add the common things and then you have to complete the square to figure out the maximum profit. And the maximum profit will be the y value. So go review that. The height of a balloon thrown vertically upwards. First of all, what does this parabola face, up or down?
It faces down.
So it has
Wait,
a
did we do that one?
Yeah, we might have. So
We did.
it has a maximum. So you just complete the square to figure out the maximum. From the maximum, you'll be able to figure the height. That'll be the y value. How long does it take? That'll be the x value. How high is the rooftop? Right here, 50.
The C value.
Yeah, because that's where it started. When time is 0, this becomes 0. This becomes 0. So the balloon started at 50 meters height. Since they say we throw it off a rooftop, it must have been thrown off of a roof that's 50 meters tall. We did that. It's in your computer. They give us the cost function. This is one I sent you as an assignment. So do it.
Yeah.
blah, blah, boom, we'll just keep going. The inverse, oh my God. So to do the inverse, you have to put it, here's the secret. You have
Oh,
to put it in vertex format. Okay?
okay.
I'm going to give you a really simple one. Here's our parabola. I'm going to even simpler. What's my vertex?
Positive 2 plus
Yeah,
1.
yeah. Positive 2 plus 1. Now I'm going to give you a very quick hint. The inverse, the sideways vertex, will always be the swap of those numbers. If I swap those numbers, I get this. Right?
Mm-hmm.
So that means whatever I'm going to find as an inverse, this is going to be the sort of the maximum. Now, what way does this parabola face? Up or down?
Up.
Up. Now, when I find the inverse, it's going to look like this.
What?
Yeah, the inverse of a parabola is a sideways parabola. Let's test that out. Here's Desmos can help you out a lot. Tell me if this is a parabola. Is that a parabola? No, not yet.
No.
No, thank you. Right. Now,
Yes.
what's the vertex?
It is positive 2, 3.
Right. What's the inverse vertex going to be then?
It's going to be 3, 2.
Yeah. So that means whatever I'm going to draw is going to start at that black dot. Right there.
Okay.
Whatever I'm going to draw. Now, the fastest way for Desmos to draw the inverse is you make this x, y, and you make this y, x. Did you hear me?
Oh,
Here we
okay.
go. And watch what happens. Ooh. Yeah, let me see.
Ooh.
Hang on. Let me see. Now, it doesn't look very pretty because it's squished. There we go. What does that look like?
The inverse parabola.
It's a sideways parabola, isn't it? What's the
Yes.
furthest? Notice that an upward parabola faces to the right. What's the furthest left point it has?
3, 2.
Ah, okay. The problem is your teacher's going to want a formula that does not look like that, but looks like that. So that means we're going to have to figure out how to, how to find the inverse formula when we're given, when we figured out this. We take this original formula, and where we see y, this is how you figure out an inverse. You take the original formula, where we see y, we're going to put x. And where we see x, we're going to put y. Now, if I put that in a Desmos, it'll draw my inverse right away. But your teacher,
So you always do that?
no, that's how you start. You start by taking this. This is how you always find an inverse. You take the original question and you put the x where the y is and the y where the x is. You're to find, here's rule number 1. Write this down. To
Okay.
find an inverse of a parabola, it must be in vertex format. That's step 1. Put in vertex format.
Tip 1.
To find an inverse of a parabola, it must be in vertex format to start. Okay? Fortunately, this is in vertex format. Step 2. Swap. Put the x where the y was and the y where the x was. Right? Step 3. Look at your y and describe in bed mass order what is happening to it. Okay, let's look at this. Bed mass says B.
Wait, repeat.
Yeah, I know.
Oh,
And step 3 is I didn't quite finish it. Describe in order what is happening to y. There you go. So let me know when you're ready.
okay. Describe in bed mass order.
Yep. Now look at this. Where's the y? Where's the y?
It's beside, it's in bracket.
Yeah, it's on the right side of the equation. So that means we have to look. Is there a bracket?
Yes.
What's happening in the bracket?
Y is being subtracted 2.
Yeah, let's write it this way. 2 is being subtracted. Right?
Yes.
Any more brackets?
No.
Now what's next in BEDMAS?
Exponent.
Okay, is there an exponent?
Yes, exponent of 2.
Describe what is happening to y based on that exponent. Or whatever's in the bracket. What is
It
happening?
is being
It's being
squared.
squared. Yeah. Okay, no more exponents. What's the next thing of BEDMAS?
Multiplication.
Is anything
So
multiplying
3.
more? Yeah. 3 is
3 is
multiplying.
multiplying.
Yeah. Great. Easy, right?
Yes.
Now, what's the last part of BEDMAS?
Addition. 3 is being added.
Yep. So, we're going to just do that. Come down a bit. 3 is being added. Step 4. 3 in BEDMAS order. 3 is being added. Good? So far, so good?
Yes.
We have completed step 3. Step 4. Look at your BEDMAS instructions. Starting at the last one, this becomes your new step 1 with reverse math. So whenever's described and numbered the last one, we will reverse the mathematical operation. What's your last step in those 4 steps? How many steps did you have?
4.
Yeah. What's the last one?
3 is being added.
So we're going to start with that one, and we're going to make that our number 1 in red. And we're going to do the reverse of the math. What is the reverse of 3 is being added?
3 is being subtracted.
Subtract 3 from both sides. We're going to repeat from both sides over and over and over. Great. Now we go up the ladder. What's step 3?
3 is being multiplying, so it's going to be 3 is being divided.
Divide 3 from both sides. On both sides. Make sense?
Yes.
Do the next step for me.
2 is being square root.
Yeah, square root both sides. 4.
2 is being added.
Add 2
In the bracket.
to both sides. Well, the bracket will be gone when we get there.
Oh, yeah.
Add 2 to both sides. Notice that I reversed the mathematical operation and I did it on both sides, right?
Yes.
So now this is my next step. Step 5. Carry out the red instructions. So we're going to start with our formula, which is right here, right?
Mm-hmm.
And we're going to carry out those red instructions one by one. What's your first instruction?
Subtract 3 from both sides.
Okay, let's do it. So on this left side, I get x minus 3. On the right side, I get x, or I have to do minus 3. So I take minus 3 on this side and minus 3 on the right side. What do you notice about the right side?
It's going to cancel out.
It's going to cancel out. That's why we did it. It's going to cancel out. That's why we did it. So that means we're left with this.
X minus 3.
Yep. What's your next instruction?
It is going to be divide 3 from both sides.
Right. What happens to the right side when I divide by 3?
It is going to cancel out.
Yeah, it's going to cancel out. Now, another trick instead of dividing by 3 is multiplying by the reciprocal. It's the same thing. And we'll get used to that, but let's just divide by 3 on both sides for now. And I'll show you the difference in a second. Your teacher might explain reciprocal. But if I divide 3 on both sides, these 3 here are going to cancel. And I'm left with this.
X minus 3 divided by 3
Yeah, is equal to,
is equal to bracket y of negative 2.
right, What's your next instruction?
Square root both sides?
Yeah. Now, here's the trick. When I square root the right side, the opposite of square is a square root. They're going to cancel. When I square root the left side, I must always add the symbol plus and
Or
minus.
minus?
Always. So if these cancel, what am I left with? I'm left with plus minus the square root of x minus 3 over 3 is equal to, the square's gone, y minus 2. But this is what I'm left with. Looking good so far. Notice that it's a radical. Oh, radical. Okay. What's the last step?
It is to add 2 to both sides.
All right, add 2 to both sides. Clearly, this is just going to come over here and become positive. Is y all alone?
Yes.
Okay. Interesting. Now, if I were to write this in proper format, it actually looks like this. See if you can tell what happened. Over x minus 3, or times x minus 3. Plus 2. What kind of function is this?
A square root
Yeah,
function.
radical function. They all look like that.
Oh.
What's the vertex of this radical function? It's the same as the vertex format of a parabola. Yeah, so what's the vertex here?
Positive 3, positive 2.
Oh, notice it's the opposite of this one, which was 2, 3, 3, 2.
Oh.
Oh, so the reverse, the inverse of a parabola is a radical function with the opposite vertex. If it's upward facing, it's going to face right. If it's downward facing, it's going to face left. But the vertex is going to be in there. This third indicates a not a compression, but a stretch because it's beside the x value. There's no vertical stretch. But that's how you do an inverse. Let's see if we got it right. So it's x, a third, x minus 3. And it can be written like this too. But I'm just letting you know this is written with the stretches. Yeah, you can see what's the stretch and what's the right-left translation. So whereas
Yes.
here it's harder to see. So let's see. That's why I was trying to introduce multiply by the reciprocal. So let's see if we got it right. So it's x minus 3 plus 2 and a third. Y is equal to square root x. We'll do a third. X minus 3. And then plus 2, I think it was. Yeah. Now, notice, and I'll turn off the other ones. This was the inverse. But when I did this in Desmos, it's only the top half. That's because this is the positive version. And remember, there's a plus minus in front. And Desmos can't draw plus minus, so I have to draw a second one that has the minus. And then suddenly, it looks more like the inverse. I'll turn this one off.
Okay.
Is it the same graph?
Yes.
That is. So notice that this was the Desmos tricky way. That this was using the inverse method. This is indeed the same as that. And even if I don't write it properly like this, observe. Is it the same graph?
Yes.
Yeah, that's right, it is. So this is just sort of, it's still a valid answer, but it's not quite written. Desmos can't handle plus minus, but you can see the plus is the top half, and minus is the bottom half.
But Mom,
You still with Peter?
I'm still studying.
Hi, Peter.
Hello.
How are you?
I'm good. How you doing?
Good, good. Just here trying to bug Natalie.
Good. Good. She's doing well.
She's studying.
Yeah,
Huh?
she's doing well, but it's complicated, and I can't say much for the teacher. The teacher doesn't really do everything properly.
What is that, Peter? Is
This-
that what you taught me last time?
No, we did statistics and fractions. This is all graphs, specific graphs.
Oh. Damn.
and the most popular graph,
That's
a
smart.
parabola. Well, she's doing well. She catches on easily, but she's got to study.
Yeah,
Yeah, she's sharp.
for sure. Peter, you know what?
What?
Uh, guess who's going to El Salvador for a week?
I'm
Also,
I'm gonna guess Lazaro and maybe you.
everybody, Peter.
Everybody.
Everybody.
Milton. Because the kids obviously, they buy their own tickets, right? Like, but then Milton is like, oh, it's not fair, like that everybody's going and Natalie's not going. Because I'm
Hmm.
like, yeah, I said like I can't afford it. I said,
Yeah.
Peter, like help me buy my ticket. And so Milton bought Natalie's ticket.
Wow, that's awesome. And wait a minute, how did I help you buy your ticket? I thought I was paying for braces. Oh,
Because
way
you
back
gave me
on your birthday
$200
gift.
for my birthday,
Your
remember?
birthday gift. I forgot all about it.
Yeah. Yeah.
Wow. How long you going for?
Me, I'm going for 3 weeks.
Wow. It's
Yeah.
cool.
But like the kids, they're going for Yancey's only going for like they're all leaving on the same day
Hmm.
on Wednesday the 10th.
Hmm.
And Yancey's coming back Monday. Yancey and Jessica are coming back Tuesday. Lazarus coming back Wednesday. So
I like.
Lazarus is going for like 7 days. But in reality it's 5 days, right? Because the traveling date.
Yeah, and plus that's a fast trip for them, but at least it'll be fun.
Yeah, because like they at least get to like be there. They because I had a feeling that was gonna happen because they just wanted me like once I booked my ticket, everybody was gonna be like, okay, I gotta go.
Yeah.
Because they're not gonna go to El Salvador without me, right? So
Yeah. Well, that's
Peter,
exciting.
why do you have a blurry thing?
Where's my blurry thing?
Your background.
Oh, so
So
students.
when you move, like
Yeah, I know.
half of you disappears, Peter. Peter, let's go to El Salvador, Peter.
I'll just bury my mother in the backyard, and off we go.
Oh, that would be so much fun if you could go.
I had a Mexican woman who wanted me to come down to Mexico, and I was like, I can't go.
You and your woman, Peter.
I know.
Leave those women alone.
I can't help it.
But like, if you go to El Salvador, you're at least going with your family. So,
Yeah, but also what's good about going to El Salvador is I'll be exotic. So everybody,
and Peter,
yes.
you get to eat pupusas
Mm,
3 for $1, Peter.
food will be good. Yeah. Yeah, I
Yeah.
wish.
So that's what the kids are excited about. Like, like the food and
Yeah.
even though it's US dollars, but
Well, one day my mom will pass and I'll go to El Salvador with you.
100%, Peter,
Yeah.
you have to come.
I'll marry some woman down there, though, and I'll have 17 kids.
Peter, you
Yes.
won't even have one kid. You're not allowed to have kids.
Well, who made that rule?
I did, Peter. You already have 4 kids.
I can have more. They're all adults. They'll be fine.
No, they're not. They wouldn't want to share.
Yeah, they're going to have to share. Let them know they're going to have 16 or 17 cousins.
Yeah, whatever.
What? Whatever.
Peter, you're not allowed to have kids. Peter, do you really want to have a kid?
Yeah.
Honestly speaking.
I feel like
Now, because when I met you, you did not want to have
well,
kids.
I was a fool.
But now, do you feel like now you want to have a kid because now you want your last name to
Nah.
keep going?
I don't care about my genetics keeping going.
But do you really want a child of your own now, Peter?
Yeah. Yeah, maybe.
No, no, no. Like you've thought about it and you say, yes, I want a kid.
I guess, yeah.
Yeah, that's good.
Yeah. Well, yeah, I was immature. Like, had I been thinking more, I probably should have thought about kids when I was younger, but I didn't really want to introduce kids into this world because I wasn't sure where it was
Like
going.
when you and I met,
Yeah.
like you were still, at an age to where you could have been a father.
Yeah, I should have. But you see, here's what I realize now.
But
Here's what I
like right
realize.
now, though, you could have been a father at like
What I realize now
I
is,
can't hear you. What?
yeah, what I realize now is when I'm getting older, I'll be all alone.
So you're worried about it being alone and you think it's for you.
Well, it'd be nice. I mean, one of the nice things about kids is that You get to say goodbye to people, and they can make sure you're okay as you go out the door. It's like coming into a house and leaving a house. You don't want to leave the house alone.
But if you live alone, Peter, like when I live alone in the summers when Natalie goes away, I feel fine.
I'm doing a metaphor
I know.
for
I'm
death. It's a
I like.
it's a metaphor for death. No one wants to die alone.
Okay, Peter.
Well, nobody wants to die alone.
Peter,
Yeah.
are you trying to grow your mustache?
Am I trying to what?
You're trying to grow your mustache?
You got to say it again.
Grow your mustache.
No.
You're studying.
This is all
Your
laziness.
mustache. You're trying to grow your mustache.
No, this is all laziness. I'm just too lazy. And I
Oh.
decided, you know what? I don't go to an
But
office.
you look good, Peter.
I know I look good. I always look good.
Peter.
Hmm.
Okay, Peter. Goodbye.
Goodbye.
Natalie just told Mom I was studying guardian, so
Yeah.
I gotta go.
Yeah, definitely got to go. Okay, bye-bye.
Love you.
Love you too. Have fun.
Take care.
Yeah.
Take care and goodbye to your future kid.
Oh. Makes me sad. Your mom was a bit of a downer there. Are you back yet, Natalie?
Peter, I heard you, Peter.
You're a bit of a downer.
I heard you, Peter.
Bit of a downer. Can't have a future
Yeah,
kid.
what do you mean, downer?
A bit of a downer.
Why?
I can't have a future kid. Jesus. Who made these
Because
rules?
of the kids?
Yeah, I don't know who made these rules.
Well, Peter,
Yeah.
I don't know if I want you to be a father.
What do you have
Okay,
to do?
you and I will have a conversation later. Goodbye.
What do you have to do with me?
Because I have 4 kids because I was very young.
Yeah.
Peter, I was young and married.
Yeah, but men don't have to do that. All he needs is a young wife.
Yeah, I don't know if I can. Okay, Peter, we will go to El Salvador and find you a wife
Yeah.
like we go there today and tomorrow you're already married.
I think that's doable.
That's how fast I can find you a wife in El Salvador and,
Yeah,
and a
and
kid
then you
and
guys
a
can
kid.
come down and visit and stay with us.
Yeah, but I have to like her too, so I have to find you a friend, okay? So you can bring her.
I'll definitely help me
Right.
find one for sure. All right, she has to study.
Huh?
Why are you doing that?
Because I was saying like we're gonna go like make breakfast and then where are we going again to the shopping?
Just ask Auntie Sully's in
No.
Valley Village. Huh?
No, she wants.
Yeah, because
I should and I told her and she's still asking.
Mom, why are you?
Bandas
Yes.
to the Talis area or
Yes.
whatever. There's a thrift stop, and there's where me and Valentin went to eat that one time. You
Yes.
and we had.
Mom,
Dairy
yes.
Queen?
Yes. If you guys are making breakfast,
Is McDonald? I mean, is there a
Thank you.
is there is
Yes,
there a Walmart there too?
Yes.
Right in front.
Yes.
Okay. Look up here to have the light on so you can see yourself.
Okay, turn on.
Mom, so much light on you.
Sorry.
That's hilarious.
It's too much. I'm sorry.
Yeah. That's kind of funny though. All right. So, what format is this in?
Standard.
Yeah. And now what does step 1 say? What does step 1 say? I'm going to just grab it. Hang on. What does step 1 say?
Step 1, put in vertex format.
Okay. How would I put that in vertex format?
Complete the square.
Yep. How?
We're gonna multiply both sides by 4. Both terms by 4.
Divide both terms by 4.
Oh yeah, I'm so sorry. Divide by
Don't ever
4.
make that mistake again. And here's what you get.
Yes. And then you're going to divide by 2.
Mm-hmm. And here's what you get.
Peter, my mom's still talking about you.
I know. She's mad that I'm going to get a wife. I don't think she wanted me to marry. I don't think she thinks it's possible for me to have kids, so I don't know why she thinks that. Men can have kids forever.
It's weird.
No, it's funny. I think she's mad that I'm looking for a wife in El Salvador instead of her.
Yeah, totally. My mom gets jealous.
Yeah, I think she's possessive. But the funny thing is, I'm sure she has lots of men suitors. So Okay, now what's next? Remember, I have to subtract a number once you figure out the square.
This square 3, so it's going to be subtract 9.
Yeah, but that 9 is stuck inside the big bracket. I have to get it out. It's stuck inside
So
the
you
big
can
bracket
multiply.
because I had a 4 in front.
Yes.
It's 9.
Multiply by 4. 9 times 4 is 30. 36.
Mm-hmm.
Plus 6 is 42. Negative
No.
42. Oh, I'm so sorry. Negative 30.
Yep. You've completed the square. Well done. Now, quick question. What's the vertex?
Negative 3, negative 30.
Yep. Which means the inverse should be.
Negative 30, negative 3.
Yep. Now, if we don't get that, we did something wrong. Let me give you a hint here. Since we know the inverse is going to be a square root function, right? We know that inside here, to be negative 30, will have to be something like x plus 30.
Yes.
And we also know that to be minus 3, it's going to have a minus 3 down up out here.
Yes.
Notice it's multiplied by 4, isn't it? So this is probably going to end up divided by 4 because everything seems to be the opposite, doesn't it?
Yes.
So really, if I'm going to guess, this is what we should have in the bracket. Since I know what the vertex should be, it's probably going to end up being either a quarter times this or x plus 30 divided by 4 because it's multiplied by 4 out there. And out here, a minus 3. That's my guess. This is what we should end up with. Why
Okay.
divided by 4? Because the parabola is multiplied by 4. And it seems like everything that we end up doing is the opposite. We figured out what the vertex should be, and so therefore it should appear in the thing. And if I were to write this correctly, I would not write it as divided by 4. What would I write it as?
As 1 over 4.
Yeah, in front. That's right. I would write it like this. But we can see that it's actually a stretch by a factor of 4 because it's inside with x and it does the opposite of x. So that's what I should see. And look at that. I was able to come up with that inverse just knowing what the new vertex should be and putting it in there. And knowing that this 4 will probably be the reverse and be divided by 4. Let's see if I was right. Follow the step. So if this is our new, if this is my new, if this is my y, if this is my parabola in vertex format, I can write it like this. Y is equal to this. Follow step 2. What does step 2 say?
Put the x where the y was and the y where the x was.
Yeah, so I end up with this. Step 3.
Yes. Look at y and describe in bedmass order what is happening to y.
Yeah.
So, bedmass order, there's a bracket of plus 3
3 is being added.
added.
Next.
Sorry, I had to sneeze. 2, it's being squared.
It is being squared. Excellent. Next.
3, 4 is being multiplied.
It is multiplied by 4.
And then 430 is being subtracted.
30 is subtracted. Very good. Now read step 4.
Look at bedmass instructions. Starting with the last one, this becomes your new step 1 with reverse math.
Yeah.
So then step 1 is 30 is being added.
Add 30 both sides.
Both sides. 2, divide 4 both sides.
You got it. You're getting better.
3, square root both sides.
Mm-hmm.
And 4, subtract 3 from both sides.
You got it. And that's how you do any inverse. You figure out the bedmass order of the letter you want to isolate, and you reverse the process. Subtract 3 both sides. Okay, let's see if that works out. Let's take the equation. And remember what we're trying to end up with. It should be square root. I should have kept it. It should look like this when we're done. Square root of x plus 30 over 4. And then it's going to be minus 3. Should be that. x plus 30 over 4 square root minus 3 with a big old plus minus in front. Okay, let's start it. Here's the equation. You follow your BEDMAS instructions. So step 5 says carry out the red instructions.
Okay. So we're going to add 30 both sides. So on the right side, it's going to cancel. It's going to be x plus 30. And then divide 4 both sides.
Just a moment. And get rid of this. What happens on the right side?
It's going to cancel out.
Yeah, so you're left with this. What's your next instructions?
Then we're going to square root both sides.
Okay, so you're left with this. What's the little thing I got to remember, little trick with square rooting?
You have to, a little trick, plus or minus.
Always. Whenever I take a square root, I got to slap in a plus minus. What happens here?
It cancels out.
Yep, so what are you left with on the right side?
Equals y plus 3.
Yep. What's your last step?
Then subtract 3 from both sides. Oh, so we did get we thought.
But notice that all we had to do was figure out the new vertex by swapping it. We knew the new vertex should be the swap, since the original vertex is minus 3, comma minus 30. That's the original parabola vertex right up here. We know that the new vertex should be this. And since we studied our functions, we know we're dealing with a radical function, so we put a plus minus here. And we would put this value as plus 30 there, and this value is minus 3 here. And then since we know it's multiplying by 4 up here, we pretty much, and it's multiplying the y, we pretty much know it's going to be dividing the x by 4. That's the only little extra trick, but at least we can predict what should be in there based on this.
Yeah.
Right? Nice trick.
Yes.
By the way, I don't have to plug it in Desmos. This is correct. If I did not add the plus minus, though, it would not be correct. You'd only have half the parabola. You need both of them. Which way does this face? Which way did this one face? This faced
Up
so this one faces.
to the right.
Yeah, so you would find this vertex, and you'd find the spot, and you just kind of draw it. You can even throw
When
it.
facing down, it's going to be to the left.
It would face this way, yeah, this way.
Okay.
And we can just see that very quickly up here. Oh. There's our parabola that we're dealing with. Let's make sure it's the same one. Nope. Yep, there we go. And now let's see what the inverse should be. The inverse here should be, if I just swap the xy's, it should be this. Desmos will just draw it automatically for me. There we go. Notice it faces to the right and starts at the spot that we're thinking about. Like that. Right, now let's see if we got our formula right. Square root 1/4 x plus 30 outside minus 3. And that only drew half because that's the plus version. And now the minus version. Looks like we got it right. If I turn this off, it's on top of the red one. The vertex is right as well. But the vertex, knowing the reverse of the vertex really helps. At least on a test, I could slam on that vertex and quickly draw it if I only have a minute left, knowing that it faces right. Now, notice if I put a minus 4 up here, my parabola will face down. Down. Which means in here, instead of a quarter, it's going to end up being a minus quarter. See if I get it.
Mhm.
If I get it. Let's see. Face down, minus 30. And we'll see if I got it right by reversing this. Yeah, I did. Notice that the minus goes here. It was out with the y. The minus goes with the x now. There we go. This one's facing down. This one's facing to the left. The vertex are indeed swapped. Good.
Yes.
Now you know how to do an inverse of parabola. It always must be in vertex format because it's much easier to.
Wait, Pete, so sorry, putting from factored format, you could put it in vertex format through distributing.
Yeah, you got to just, that's right. So if they give you this version, you cannot do an inverse until you put it in factored format. Although technically you could cheat. What are the x-intercepts going to be there?
It is going to be -4, -6.
Right. What's the halfway point between -4 and -6?
-5.
Right. So that's the axis of symmetry, isn't it?
Yes.
So I can put that in there. What do I get? Solve the brackets for me.
It's going to be -1
Uh-huh.
and +1.
Uh-huh. Multiply that out for me.
It's going to be -1 times 3, -3.
So that means my vertex of this parabola is -5, comma, -3. Since there's a 3 in front, I safely presume that this will be the vertex format. Little cheat. Let's see if it's true, but that's a good fast way to do it.
Yeah.
And I knew I had to put the 3 up front here because there's a 3 up front here.
Okay.
Bummer. It's a real bummer if they put the 3 in here. You cannot use this method. You can only use this method as the 3 up here. If the 3's in here, it changes the x-intercept entirely. Yeah, you'd have to expand it.
So what you do if the 3 was in there?
Yeah, well, if the 3's in there, the x-intercept changes. Look. Here. Either one of these brackets must be equal to 0 to figure out what the x is. Solve the x for here. How do I solve? How do I get x all alone?
X would need to equal 6.
Yeah. No. You subtract 6 from both sides. You're subtracting 6 from both sides to get rid of the 6 here. And you're left with that. So that's one x-intercept. This one must be equal to 0. Solve for me. How do you solve?
X would need to equal. Wait.
So this is the same trick. What's the bend mass order? What bend mass order of what's happening to x?
It's being multiplied by 3 and 4 is added.
And 4 is added. Reverse those steps.
4 is subtracted and divided by 3.
Subtract 4 both sides. Divide 3 both sides.
Okay.
Okay. Do that.
So on the left side it's going to cancel out, and then on the right side it's going to be 0 minus 4.
I should just put the 4 over here, -4 over here. Yeah.
And then divide by 3, so it's going to be x equals -4 over 3.
So that's the new intercept. These are the two intercepts. Is it the same intercept as before?
No.
That's why you can't use this method when the 3's in there. By the way, this trick, bed mass order, is what you always use to do algebra, to solve this situation. Always. Just describe bed mass, reverse it. Right? That's what algebra is. Yes. It's solving for x. All right. Let's just do a little bit more. And then we'll call it quits. So they're just spending the whole time teaching you to do an inverse. Notice the plus minus here in the textbook over and over again.
Yes.
They put the stupid -3 at the end. I don't like that. This just means the inverse. That just f to the -1 of x means the inverse of f of x. See how it says this little -1 is like a kind of an exponent over f? That just means, so if you see this, find this, it means find the inverse. Right there, it explains it.
So wait, if I put the -3 like inside,
It'll be the
like how they're
same
usually
graph.
doing it?
It'll be the same graph, but really technically, the way we've been describing translations, the -3 goes to the right side. The book, for some reason, has put it on the left side, but in reality, the reason they did it is, I don't know why they did it. Screw them. I don't care why they did it. They're stupid. See, okay, here's proper. That's proper. The translation's on the right side.
Yes.
All right. So then they just ask you to do a few inverses, and then they just go make you practice the inverses. This is tricky. We can't cover that right now. Same thing here. They get you to do the inverse.
What about 4?
Mm-hmm.
Question 4?
Mm-hmm. Okay. Sure. Yeah, you're a little weak on this stuff here, on this, what these terms mean. Yes, question 4 is annoying. Question 4 is annoying. So they're saying that x is bigger. In this case, we're only concerned with x to the right or equal 1.
Okay.
Okay? Now, they've written this stupid parabola in a way I don't like. In my opinion, this parabola should be written like this. Because you can see the vertex now. What's the vertex?
It is +1, +7.
Yeah, is it facing down or not?
Down.
Okay. So that means at 1, 7, that's the vertex. But they're only concerned with the right side of 1. So they're only concerned with half of this parabola over here. This just means focus on only the part of the parabola that's to the right of 1. Which is, here's the vertex. It means it's on the right side they're focusing on. It's kind of stupid. Now, how would I find this? What does this mean?
We have to plug 3 into x.
Yep. This means find y when x is 3. So if we rewrite this, we got this. But everywhere I see x, I just put a 3. Solve the brackets first. You go in bed mass order.
3 minus 1 is 2.
Yeah. What's next in bed mass order?
It's 2 times 2, 4.
Nope. Oh, did you square it?
Yes.
Yeah. Okay, you're right. Sorry. So that's 4.
4 times -2 is -8 plus 7, which is 15.
No.
No, sorry, -8 plus 7 is -1.
Yep. That means f of 3 is equal to -1, which means when x is 3, when x is 3, y is -1. That's all it means. Oh,
Okay.
what's this mean? What are they asking here?
What are they asking there? The inverse.
Yeah, the inverse. So that's the trick, right? When your teacher asks that, I don't want you to go, what the hell? Peter didn't teach me that. God damn you, Peter! Okay, quickly, what was the vertex here? You told me already.
It is a +1, +7.
What should the inverse vertex be?
7, comma 1
What kind of graph will the inverse be? Like what kind of function?
to the square root function.
Yeah. Since this is a 7 and this is the 1, what should I see in here and out here?
You should see x plus 7. No, x minus 7. X minus 7. X minus 7. And then outside would be +1.
Yeah. Notice that this is being multiplied by -2. What do I suspect will be over here?
Divide by -2.
Yeah, and we'll just put the negative up here and put the 2 down here. Because your teacher doesn't like to see the negative down here. So that's what we should see, or, more properly done, -1/2 in front. Look at that. We found the inverse without actually doing the work.
Yes.
Yeah, it's a good trick to know so that you know if you got it right or not. But your teacher's going to want to see the long way. The long way says describe in bed mass order. Go. What's happening to x? Well, first you swap the x and the y. First you swap the x and the y.
Okay, so x equals negative 2, y minus 1.
So, in
So,
mass order, describe what's happening to y.
first, 1 is being subtracted.
Yep.
2, it is being squared.
Mm-hmm.
3, it is being multiplied by negative 2.
Mm-hmm.
And then 4, 7 is being added.
Find the new
And
rules.
the new rules is going to be 7 is being subtracted,
Subtract 7 both sides.
both sides. Then divide negative 2 both sides.
Mm-hmm.
And then square root both sides.
Mm-hmm. Don't forget to
And
add
then,
the plus minus.
oh yes, plus minus. And
Mm-hmm.
then add 1.
And then add 1 both sides. Great. Let's try it out. Carry out those instructions with this graph right here.
Okay. So subtract 7 both sides. So it's
Okay.
going to be
Yeah.
x minus 7.
Uh-huh. Hang on. Oh, no. We go there. We get rid of this. Notice it's kind of the reverse every time. Instead of adding 7, it ends up minus 7. That's
Yes.
done.
Divide negative 2 both sides.
Okay. It always cancels out on the right side, so I can just kind
Yeah.
of do this. Your teacher likes to
Erase
see the
that.
minus up top, but we'll get to that. Next.
Then square root both sides.
Right. Add the plus minus.
Add the plus minus. So then it's going to be y minus 1.
Mm-hmm.
And then add 1 to both sides. So it's just going to be equal y
Didn't
plus
we
1.
predict this? What's the
Yes.
proper way to write it in the bracket over here?
It's going to be negative 1 over 2.
Don't forget the
Bracket
plus
x
minus.
minus 7.
Yeah.
Oh yes, plus minus.
Negative 1 over 2 times my x minus 7 plus 1. What's the vertex of this thing?
It is plus 7 plus 1.
Yeah. What was the original vertex?
It was 1, 7.
Did you get it right, do you think?
Yes.
Yeah. Which way does it face? This faces down, so this will face.
To the left.
So that means you can find 7, 1, and just kind of draw it like this. Whee! All right. What are they
Alright.
asking for here?
The inverse, but with 5 equals x.
Yeah, so what do you think I do?
So you have to substitute 5
Into which
into
equation?
x.
Into which equation?
Inverse.
Yeah, into the inverse. They're asking you to find what the y is for when x is 5. So that means where I see x, I just put in a 5. Now
5.
this is tricky. So I'll explain the trickiness. So where I see x, I got to put in 5. Hang on. I'm going to replace x with 5. 5 minus 7. 5 minus 7.
Is negative 2.
Yeah, so that's going to be replaced with negative 2 divided by negative 2.
So that's going to be 1. Or
Yep.
it's going to cancel?
Yeah, no, they cancel, but anything divided by itself is 1.
1.
Now, here's the tricky part. What does the plus minus mean? It means I have to find 1 where it's the positive version of the square root of 1 and add 1. And then I have to do the negative version of the square root of 1 and add 1. Let's start with the positive version. What's the square root of 1?
1
Yeah, make it positive. So, okay, it's positive 1. Add 1.
plus 2.
2. So when x is 5, which is what we started with, y is 2.
2.
Now, square root of 1 down here?
Negative 1.
No, yeah, square root of 1 first.
Oh, 1.
Negative 1 plus 1.
Plus 1 is 0.
So the two spots we should find is 5 comma 2, 5 comma 0. Let's see if that's correct. We're going to take the original formula, which is this. Written properly. I don't like their stupid way they wrote it. Right? We determined
Yeah.
the inverse should be this. And it's got to be a positive version and a negative version. We'll call this first one f of x. And we've got to make another negative version because I can't put plus and minus. I think there's a way to put plus and minus, but I don't know it. So I got to put a negative version down here. Good. Now I'm going to bring up this. All right. They were asking about what f of x is when x is 5 for the inverse, right?
Yes.
We figured out the inverse. This is the positive inverse. This is the negative inverse. So first I'm going to figure out what f of 5 is. It's 2, like we figured out, 5 comma 2. And then I'm going to figure out g of 5, the other one, 0. We got it right. So that means for the inverse, when x is 5, we get 2. But we also get, when x is 5, 0.
0.
Because there's 2 points. Because this is not a function. The sideways parabola is not a function because it doesn't pass the vertical line test. But there's those points.
Oh.
Right there.
Yes.
What 2 corresponding points on the original graph would these be?
It would be 5, 0.
Almost.
Oh, sorry, 0, 5. And
Yeah.
then 2, 5.
That's right. The inverse. The switch. Because really, the inverse just means switching your x and y's. Oh, so these are the corresponding points. And that's the, so if she said, these are the original points, what are the inverse points? You just swap them.
Yeah.
Yeah. Now, what the hell is this asking?
Yeah.
What the hell, Peter? I don't know. I said, ooh, I don't want to do that. I don't want to do it. Okay, but you've already figured out the inverse formula right here, right?
Yes.
This just means wherever I see x, I'm going to put in what this is.
2a plus 7.
Yeah, so I got to do 2a plus 7 minus 7. Just taking this top part here. I'm doing it here. I'll make it bigger. Put this there. It's 2a plus 7 minus 7.
It is. Wait, say what one more time here?
Yeah. So this just means wherever I see x, put this in. This is the inverse. Didn't we have an inverse formula right here?
Yes.
Right. So where I see x, I'm going to put in what?
2a plus 7 minus 7.
Where do I see x? Right there. Right? Right here.
Yes.
So instead of x, I'm going to put in
2a plus 7.
Yeah. Then I'm going to resolve it mathematically. I can't subtract 7 from 2a, but I can certainly subtract 7 from
7. So it's going to be 2a over negative 2?
Yeah, so I can't divide a by negative 2, but I can certainly divide positive 2 by negative 2.
So it is going to be negative 1.
Yeah. So you might say, Peter, I can't have a negative inside a square root. You told me that. There's no such thing as a square root negative. However, that a ended up being negative. That negative thing in front of it would make it positive. So for all negative values of y, we can indeed take a square root. Can I solve it further than that? No. So that means this is equal to plus or minus the square root of negative a plus 1, like this. And that's as far as I can go. So if she gives me a, I can solve it. For all values where a is positive, no answer, because this would make a square root of a negative, which can't happen. But for all values where a is equal to a negative number, this negative 1 times that negative number would make it positive. I can make a square root of it. I can make a plus minus of it. So I do one that's plus, one that's minus, and then add 1. So it depends what they tell me a is. But since they didn't tell me a, since they did not tell me a, this is as far as I can go.
Okay.
Makes sense, right? Just substitute x for what they see and solve all the numbers that you can.
Okay.
I think that's it. There's more to be done. We would start with, this is 3.3, not bad. But you should keep working your way through the textbook, because the textbook is where she's grabbing her questions.
Okay.
So we're at 3.3. Next we're going to 3.4, operation with radicals.
Yes. I'm
Mm,
glad I went 3.3 because she's probably going to teach it on Monday or Tuesday.
good, and we'll go over it on Monday and Tuesday, right? We're doing Monday and Tuesday? Okay.
Yes.
I would urge you to do the questions I sent you. And actually, I'm going to resend them. I'm going to resend a couple questions.
Okay.
Just practice, practice,